Hello, hello. Um, that's probably fine, I guess. It's hard to know on the terminal, but it's fine. Okay. Today's agenda. Last time we left off, I am successfully generating structs from templates. You can have generic types passed in. You can have like sizes for arrays passed in. But I want you to be able to declare a function like this that just takes the name of your function template, right? Even though behind the scenes so actually my current example is using this. I want you to be able to pass just this, right? Just the name of the struct like you would normally. But behind the scenes, I'm generating a 128 sized one, a 512 sized one, a 1024 sized one. You can see here they are 3 different structs. And they're named, they're like tagged with a certain name to let you know which is which internally, because they have to be different. I don't want you to have to think about that down here though. When you make a function, just pass me the thing and it'll generate the right function versions of those functions for you. Initially, I thought I was gonna have to do a lot of work and kind of figure out, kind of handle the matrix of functions versus structs and how those all go together. But then I realized yesterday, I already have a system that does this. We already have this any of syntax that you can pass it. You can say, hey, this argument can be anything limited to these types. So anything in this set of values, and it'll generate those for you. So I realized, well, if I know every type of struct that you instantiated, every type that you instantiated, so if I know you did a 128, a 512, a 1024, which I do know because they're all right here, I have to spit them out, then instead I'll just take your function, and instead of this being your function, it will go generate one that looks like this. Right? It can just go generate this. And that does all the work for me. All the support is there for this to just work. It's going to be piggybacking off of the any of system, which we already have. I already know what all struct types I generated for you. So why don't I just piggyback off of any of? It's already got error reporting. It already does all of it for you. So that's the goal today. And I don't imagine it'll take very long because the any of system is already pretty powerful and does what it needs to do. So my goal here is to take this, and I want to be able to print out, I want to take a pointer to one of those and print bucket size that. And currently this should not work. Because this function currently is just a function that takes one of these base structs, which is a template, so that's just not going to work. Right? It's like, yeah, I don't know what an integer storage is. I know what a 512 is, for example, because that's what we generated over here. But yeah, so let's get to work on that. Let's go to the metaprogram, and I think what we can do is let's have another step here. So after we generate struct templates, we will create generic versions of function. We'll say, yeah, generic versions of functions that take struct templates as any parameter. So we'll just call this generate generic struct template functions, I guess. It's a very bad name, but it's fine. Okay. So it's going to take the AST, so we'll just yoink it from here. Okay. So we are going to say, the first thing I need to do is find any function that takes a struct template as a parameter. And I think, let me verify this. I think that information should be in the tree. I think. That did not. Right. Oh. Right. It doesn't actually know. Well, actually, let me look at the tree. Hold on. I got carried away because of the error. Freaked me out a little bit, but it's okay. My function, it's a void. It takes a decal param, which is a integer storage. What I want to know is what that is. For each node of type in tree AST, I just want to print out every decal param, and this is the lazy way to do this, but I just want to see what they are. So because if it's already a struct template, then this job becomes way easier. Integer storage. Oh, I guess it's not an integer storage by definition. It is a decal param. So, but its type node. Its type node should be info decal variable type node. That's really what I want. And I only want to do this if node type, no, if decal variable dot name is, or dot type integer storage. So I just want to see if we point to the actual function or struct template, then our job becomes even easier, which, hey, look at that, we do. So I really just have to loop over every function that takes, if any of its parameters are a struct template, I need to generate a version of the function for every one of the instantiations of it. So this should be pretty easy. So let's look for every function in the whole tree, and has a generic parameter, generic struct parameter. So we're going to each node of for each child in the, let's make a alias for it, decal, for each child node in decal. If child type is not equal, we're not interested in anything else but parameters. And then if child if it has a type node and its type nodes type is an AST meta-struct template. Let's just print it. Right? So we're just going to loop over all the functions in our program. Any of them that have struct templates as a parameter, we'll see them here. And in fact, let's not print the child, let's print the decal itself. So there we go, my function shows up. And let's do this. /n. Let's do a print node nicely here. So there we go, my function returns a void. So if I write another one over here that takes a test function, let's have it take this AnyStruct2. This should also show up here, which it does. Cool. So we can easily recognize them. That's part one. We'll say has generic struct parameter equals true, and then we'll say break out of inner for each. And then we will also say here if has generic break out of inner for each. Those are just some helper macros that, oh, maybe I don't need to do that. It's just break out of for each. What is break out of? Break out of inner for each. Oh. Maybe that's okay. I was using that in a place where I can't break out of. Yeah. So I can't actually break out like that. So let's. I mean, that's fine. We'll just do what I did before. We'll break out of the for each in either case. So we'll break out of that for each once we find one, and we'll break out of the farther one. Okay, so now if oh no, we don't want to do this. Sorry. So for every function, if this one has a generic struct parameter, we are going to I guess first we need to match the generic struct parameter to the struct, which is easy because we have the type node. So how am I generating that right now? You know what? Let's put this with generate struct templates. So it's in the same place. Let's put it up here. Oh shit. How did that happen? Okay. So, generate struct templates. If it has a struct parameter, then how am I generating the name right now? generated struct, create structure, generated name. Struct name from call and template. So, I need both the call site and the template. I feel like since this is coming after our struct templates, always, although I just thought of a problem. This is assuming the only structs that you're generating and the only functions you're generating are coming from templates and not via a metaprogram. Which I don't think. There are a lot of cases right now where that's kind of a problem. I think I'll come back to that later though. So, in fact, I'm going to put a to do here and say, doesn't this and other things with templates break down when metaprograms generate these things and not other templates? Need to think through this and come up with an example that breaks to build off of. Worry about that later. Although maybe, did I already say that here? If any user level metaprograms generate new types based on call sites, it will break in precisely the same way. One potential solution that still feels band-aidy would be to separate metaprograms into classes that run at different times. Yeah, okay, that's pretty much what this is saying. So, already have a giant to do here for this exact scenario because I've already hit it before. We'll come back to that, it's fine. So, if we have a generic struct parameter, then let's get the template. Wait, this is per parameter though. So let me think here, because we're basically saying I wonder if this will just work recursively. If we just handle one of these at a time, this might just work recursively through every pass of the metaprogram. Okay, let's do it this way then. Because yeah, this might actually just work. We'll make this an S32. It's going to be -1 by default. And if it has one, we're going to set a generic struct parameter index. I think this can run recursively, taking care of one param at a time, which will generate more, which will eventually finally resolve on future passes. Verify, and then remove this to do. So the first time through, so say if this takes two things it has to resolve, The first time through, it'll resolve this one and generate function definitions where this one's resolved, but this one still isn't. But because that generated more stuff, the second pass will come through and do it for the next one, I think. I think that'll just work in this system. So if we found one, we want to generate a function. So okay. So we're gonna say, let's grab the template. We need the template. I almost wonder if because we're doing a lot of the same work up here. Because once we're here, maybe we can just do this here, actually. Let's, no, because if it has multiple, that won't actually work. Let's just keep doing this for now. I think we're duplicating a lot of work, but it's fine. The metaprograms are really fast right now, so it should be okay. So the template is child info variable.type node. And let's just assert, this should always be the case, but template type should definitely be a struct template here, because we already verified that before, but just might as well double check. Okay. So we have the template. We now need to find every instantiation of it. This is where we're doing extra work here. Oh. Okay, we actually already have... This is less bad. I forgot that we actually have a flag on decal variables. We've already done a pre-pass and found all of them that are struct template calls. So that makes this easier. So, well, no, it doesn't, because this is not a template call at all. We're just matching by name. So I'm trying to think about the cleanest way to do this. So here we are actually, okay, we are actually doing a very similar thing here. We are, in fact. So let's just copy this and let's go back down here. So what we're gonna say is we have the decal. Let's also grab the info just in case we use that. Do we use it here? I'm sure we will. Okay. And you know what? Let's also grab the name so we don't have to repeat ourselves. Template name is child info dot decal variable dot type. So we have the index, which we need. Okay, here's where we actually do need this here. I'm going to take this back because this actually is going to mirror this other thing quite closely. So if we found a generic struct parameter, we are going to loop over all of... Oh, damn it. I need it... I actually need it for all 4 of these cases. So this to do kind of needs to happen right now because I need all of 4 of these to happen in one place. So let's detour really quick and add that for each node of type in tree. We pass it a single type. I want to be able to pass it multiple ones. So we're saying get nodes of type. Get nodes of type. Let's make a second one. And we'll call it get nodes of types, plural. Even though that's a little goofy. And node query result, we'll say AST node query types input. It's going to have types, we'll just say 8, I guess. It really doesn't matter. We'll just do the dumbest thing possible. It's fine. So get node of types. Instead of this, we're going to pass it a AST node query types input. Types. So get node of types, node types. Okay. Get nodes of types recurse. This is now a node input query. Okay, so we're gonna loop over the types that were passed. Num types. Num types plus type index. And if the child type equals node types types type index, then we'll do this and we'll break. Super easy. And then finally, we want another 2 of these that say for each node of types in tree and for each node of types types. Yeah. And you know what? There's no reason for these to be pointers. It's like hardly any data we're passing to this thing. So of types. These can just be this. That's fine. A little gross, but you know what? Sometimes that's just how it goes. Oh, I am not done with what we were doing. So before we do anything else, let's just verify that that works. I'm going to comment out what we're doing up here. So just hold your horses. Util 361. Get nodes of types, recurse. 361, wait, node types. Oh no, I screwed that up. Oh no, I didn't, that's right. Okay, let's go back to what we were doing here. Let's comment this out really quick. That works. And now if I change this to just this, AST inputs, template types, we're going to say 4, and it is variable AST decal param, AST struct member, AST union member, and these aren't strings. I messed that up. These are metagen parser node types. I think that just works. So this can take template types, generate struct templates. This will take one of these types for each node of types in tree types. Um, 476. For each node of types in tree, what did I do? Of types in tree. Get nodes of types. Oh. For each node of types in tree. Cannot convert that to get nodes of type. Get nodes of type. Oh. Right, when I actually make the call in here, get nodes of types. Node type on 63. Wait, what? Get nodes of type, and we look at if that one's type is node type. Why do we have this here? Don't we know it's that type? If child type equals node type, we add it. Yes? And then here, query number of nodes. If the type of the node there is that. That seems superfluous. Why do we have that there? We're already doing that check when we do the search. Okay, that worked. Weird. I I don't like programming in a macro like this because it's just confusing, and I think that's a case where I just got confused. So great, we can do this now. Question is, can I just pass this directly in here? Does that work? It does. Okay. Whoa. Cool. I can do that. Let's do it this way. We're passing 4 in, and they look like that. Okay. Coder doesn't know how to make this look nice, so you know what? I'm gonna leave it the way I had it. Screw it. Coder can't figure out a nice way to frame this, so we'll just do it this way. Okay, so that means, where were we? Let's go back to main. There you go. Let's go back up here. Uncomment all this stuff. Crap. Oh no. There's a lot of stuff about Coder that frustrates me. This is one of them. I can comment out this whole thing, but I cannot uncomment it as easily, so we'll just do this manually. Nope. Okay. I can actually do it for some of these. It's just when I hit a comment, I need to not, because it screws it up. Like there. There. Okay. So, we're gonna say, so same thing here. We want this same AST query. I'm gonna say possible template generic. We'll say generic node types. Generic nodes is this. God, I don't like. It's gross, but whatever. It's fine. For generic nodes, we're going to find nodes of types. And now we're in a place where you know what? I'm going to remove this stuff because I need to get my bearings again. So if we found a generic struct parameter, a function that takes one, we want to look over all the generic nodes. We want to see you see, this is why I think this should be happening when we generate the struct template itself. I think. I think that makes the most sense here. So where do we add it to the function or add it to the program? So here, add struct equal to program. I'm just going to print the generated struct here. And in fact, that's not what I'm doing here. I'm doing the add struct equal to program. I want this. Oh, it returns the node. So I just want this for now. Generic struct parameter, what? You know what? I am actually gonna forget about this entirely. We're gonna do this a different way. So, yeah, forget about this. Let's call this. And okay, so yeah, you can see here every time I generate one of these, but what if it takes both? That's the problem. This is trickier than I was thinking it would be. We already did that. So, what needs to happen here is I want to create a copy of this function for every one of these that was generated in your code. I wonder if I can just modify this in place. Any function I find that takes one of these, I can just modify it in place. Maybe? Let's try that. Let's try that. Let's modify the function in place. So, here, when we create one of these things, find any functions that take this struct template as a parameter and add this generated one as a any of parameter. The thing is, I would like to do that at the very end, once I know I've generated all of them. Like, I almost wish that this was backwards, that I could... No, but it has to be this way. Okay. This is turning out to be hairier than I thought it would be, which is fine, because this is going to be a sick feature, but I just got to figure out how to do it correctly. So maybe I can do this in a post pass if I augment something here. So if I augment the Okay, I actually don't have struct. Multiple node types use this struct. AST-decal struct. AST-meta struct template. So what I'm thinking of is I can add on to here a list of all of the templates that got generated off of this template. All the structs that got generated off of this template. And if I had that, then it's just a single pass, right? I think. I see this. This takes me to the struct decal for the template. And from there, I have everything that I need to replace it with. That seems cleanest to me. It takes a little more memory, but again, memory is a lot cheaper than doing all of this other crazy stuff, I think. So list all the structs that, if this is a struct template, sort list of all of the structs that got generated from it. So we're going to take a num generated from me doesn't have a value, duh. And these are all going to be pointers to nodes. Generated from me. I don't know. This is going to be an arbitrary number. I mean, okay, so forget this. When we add it to the program, we are going to say generated node is this, and if generated node template. Do we have template at this point? Where's template? Template is in the for each. So yes, we definitely have it here. For each. So template info. Do I have template? Do I already have that somewhere? Info type node template. No. So template info decal struct dot generated from me. Oh, hold on. I don't want to do this if we already have this one in here. Add struct decal program. Oh, we already don't return it if it already exists. Cool, great. If we did actually generate a node, then generated from me index equals this. What is happening? Num generated from me plus plus index equals generated node. Right? That should just work. Okay. And now we're going to say we are going to bring this function back. We're going to do it in a post pass. generate generic generate functions with generic struct params. I like me some verbose function names, it's fine. Generate functions with, okay. Okay, we're gonna basically do what we did before, right? For each node of type in tree, decal function. Do we need to do the, do we need to find the exact one? I think so. I think we do. If we're gonna modify the tree in place, then okay, we'll do this. Decal, or we'll say function. Yeah, we do. So S32 generic struct param index is -1. Okay, we're gonna do literally what we just did before. Function if child type does not equal AST decal. Actually, let's not even do this. If it equals an AST decal param and child info decal variable type node and type node type equals AST meta struct template. If all of these things are true, generic struct param index is no, this is coming after the fact. We've already generated them all, so we actually don't need to know this. We just have to know has, right, we just have to know if it has any struct param equals false. So if that's true, has is true, and breakout. So we'll say if has, I realize we just did this, but now we know a lot better what the problem looks like, so that's fine. Just redoing a little bit of work here. I realize this has to be node. Okay. But this is also not going to compile yet because these don't make sense to the program yet. Okay. Although we didn't print anything because we're not. Why are we not? Oh, because I remove. It would help not to remove this. What? If, oh, this is not inner. Oh, that's gonna break me out of, no, that was actually, that's fine. That worked just fine. Weird, okay. So, we found them, great. So now, what I actually want to do is print out the AST of this function. So now that we have this, now that we found the function decal, like the node on the tree, I want to replace this wholesale with one that takes any of, an any of parameter, right? And let's quickly see what that looks like on the tree, because I don't remember. I don't remember what that looks like. Any of. Okay. I really hope that is not just a string. Oh, no, if it's just a string, this actually helps us quite a bit. Let's see how that's stored. Parser print AST any of. Okay, it's an array of variables. So, great. This should be quite easy. If it has a generic struct param at all, we verified it has some. It has at least one. Let's. Do we really have to do it this way? No. You know what? Screw this. Why even go through all this hassle? Let's just do it right here. Right? Let's not break. Let's just do it right here. For every child that's a parameter, that is a struct template, let's just do it in place. Why am I going this extra step of routing around the... There's no reason to route out of this for loop. Let's just do it right here. So, if we found one, let's make sure this is still what we're looking for. So, we want to replace the types in this param with an any of for all of them. So, let's look at what those look like. Num any of types, and it's just an array. And it's still a parameter, so I don't actually have to change that. This actually is going to be pretty nice to do, I think. We found a function that had this param we'll do it this way. Let's make a alias for it. This param has is a generic struct. So let's change the type to any of with each generated struct as an option. Okay. So, what we're gonna do is let's really quick print the param just so I can see what it is. So value is the name, the type is integer storage, star, so it should be an any of star. So let's do that first. Param type should be equal to, it's still a parameter, so actually let's grab the info. What do I call these? Decal info variable. Info, we'll say param info. Okay, so param info. Let's see. The type node can stay the same. It's pointing to the struct. That's fine. Or the template. That's fine. So I need to find. First, we find how many. No, wait. This is. I'm storing this on the. Oh god, this becomes very, very easy. So we'll say template is this thing. So what we can do really quick is just let's print out the template that this belongs to. Decal variable. This becomes really easy actually. So here's the template it belongs to. I should be able to grab the number of things it's pointing to, because that's what we just added, right? This num generated from me. I should be able to grab that now. So let's write int generated from num generated from me. Int to string, template, info, decal struct, num generated from me. So, just to verify up front, any integer storage in any struct2. Let's see what we should expect from this, assuming that code worked. Any struct2 should have 0. We're not using it anywhere. Integer storage should have 3. We've generated 3 different structs out of it. 3 and 0. So this is going to be really easy. So for each of these, we're going to say function, or no, parameter. What did we call this? Num any of types. So first let's change the type, right? Is type just any of? Oh, it's a property, okay. What do we set its name to though? Type, get token text, type. Oh, it's just any of. So, param, info, type is any of, param, actually, yeah, let's just make this look like it should. So type is any of, type node can stay the same. Flags, we're gonna or in. Property type any of. And we're gonna set num any of types to this. How many have been generated from me? And finally, we are going to num struct types is equal to this. So we'll say this is num struct types for type type index 0, type index is less than num struct types. Okay, so now all we have to do is append to this array. Oh, first we have to make the array, right? So param info any of types. We're gonna push an array. The AST's arena. These are dynamic strings, and there are num struct types of them. Okay, param info any of types, type index equals this generated from me type index. I think that's it. There's almost certainly going to be a problem here, but I think that's kind of all we're looking at. The AST. Oh, do I need to pass the arena? What am I using? Oh, global parser. Oops. It's been a while since I did this. This is the global parser. Any of types, type index equals generated from me. Right, this is the generated type struct. This is going to be generated struct info decal struct dot name. Dynamic string and short string. Oh, this is a right. This needs to be allocate dynamic string. global parser arena, and we're passing it the initial value, which is the name. Oh, allocate dstring, that's not what it's called. Arena size, do I take that? Okay, we didn't crash. Do we have an allocate? With an initial value? Yeah, we do. In fact, I'll pass the pointer to that. So we didn't actually crash, but we're not seeing what we wanted to. So let's print out the tree again. Or no, let's print out the parameter after we're done doing this. So, or let's print out the function after we do this. No, let's print out the parameter. Print ast param. Let's just see what we did. Any of. So that looks good to me. We generated one for each of them. If we don't ever use it... Okay, we'll come back to that case later. Let's remove that for now, because that's a case where... if we don't ever use it... If we don't ever use this, so we never generate any type, any structs from the template, then the function param replacing stuff breaks. Think about this. Okay, let's take that out for now. Test function declared void. Right, let's remove this. This may have actually worked, and this is the part that's failing, so potentially. If we see this bucket size thing get printed, then we know we're good. My function declared void. Okay, so that didn't work. Let's see what it generated. There's these. My function is not in here. My function is not in here. Nor is it in there. Okay. Let's look at this. My function. Oh. That's bad. Any of was not okay. Why did it do that? We gave it the any of property. Okay, it does want it to be this. I don't think that matters though, because we're not matching on the that, are we? Oh, we might be. We are. That's bad. Why are we matching on that? This should be enough. Okay, let's see what we're generating now. My function, nope. My function, nope. My function. Okay, I mean, it's still not what we want. Okay, so that's why it doesn't actually matter that that's that. Let me look at any of. Okay, it looks like it does have the. Are we doing that in the printing though? Any of. Yeah, we're doing that in the printing. That type name should literally not matter. So that makes me feel a little better. So forget that. We give it the any of property. Push array. That should work. And if I print out the param, that looks right to me. So why is it not getting generated? Oh, because now I need to label this function as a generic function. So you know what? Let's actually do this way. Generic function equals false. If we get in here, generic function is true. In which case, if this is a generic function, then we will. What do I have to tag it as? This is a function template. Function type equals. There you go. There's no way that just worked. There's no way that just worked. My function. My function. Although, why is it not showing up here is my question. The fact that it's not showing up in any of these chunks confuses me. That confuses me, but if I look here, my function. Wait, what? It's not showing up anywhere. Oh, wait, this is not the part that I'm excited about. I'm just excited that it compiled. It doesn't mean we actually are calling our function. Duh. Okay. Let's call a function this time so it tries to generate it. Yes. So my function was not declared. Now let's go look. Did it try to generate it? My function, no. My function, no. No. Okay. So, got a little excited. That's okay. I'm excited about this thing. So, my function. Okay, it didn't generate it at all. So, it didn't even try to generate it. So, I'm missing something else here. If it's a function template, what else needs to happen for function templates? Parser, no, CodeGen? Is it in CodeGen? Function template. Although this should handle it for me. Although I guess when does that happen? Update function templates, AST post pass. So it does a post pass, runs the metaprograms, does another post pass. That actually should have just, it should be doing this for me. But it doesn't. Why doesn't it? Oh, because it only runs on the, never mind. If I'm modifying the tree in place, I have to do that before. Whatever. That's not the problem. So function template. So that should be happening here, and we should be doing it at this step. Let's print out the function. Here, let's just print it out. Print AST function. Okay, my function is a function template. It's got a parameter that's any of these things. Boom. So it's seeing it. It's just not generating it. For each function call. Oh, did I not update? No. Oh, is it not getting matched? Ooh, it might not be getting matched. Damn it. Okay. This function call is probably not getting matched to this function. Because I'm passing it one of these generated structs. This function call. Well, no. If it doesn't have a decal ref, that's where we do this at. Feel like I'm gonna have to step through this and figure out what's happening because this doesn't make sense right now. Let's step through it. Let's pull out VS Code and step through it. Okay. Generate struct templates. Let's break off this. Okay. Let's go here where we actually modify one of these things. Okay, it just didn't. There it is. Okay. So we see it there, right? It's a function template, my function, returns a void. There's the parameter. Can we look at this function and see node flags are 0? Does it need a certain flag on it? No. So those are those kind of flags. And those are those kind of flags that shouldn't be. Okay, let's just step through it. Let's keep going. So let's go. Don't need this anymore. Let's break here. We generated all the struct templates. We modified all the function decals. So now let's generate function templates. Function call. Let's break if the function call is on line 73. Function call line number 73. And this one is nope. My function. There we go. And we're pointing back to the function template. So we are pointing to the right place. So we should be able to update. We should be able to generate this function. So its first child is a decal ref. Its second child is a unary operator pre. It's the ampersand, right? And its first decal ref is small bucket, which points to the variable. This should all be just fine. And small bucket its type is integer storage 128. It's what it should be. We've already taken care of all the structs. So, okay. So, here's the function that we're trying, the function call we need to generate a function from. We're not inside a function template. We're not part of a snippet. Oh, we have a decal ref. Okay. The decal ref is my function. Generate function templates on all of my parameters, but my parameters are not wait a minute, where are we now? Where has this taken me? Are we like down in? All right, I'm confused now. Yep. This is my function. Let's kill this breakpoint for now and just step through this. Oh, we failed this check. Okay, that tells me something. We failed that check. That's what happened. Decal ref decal node. So we failing that. The decal ref is my function, if not decal node. But it does. It exists. It's right there. Why? Why is that happening? Decal ref. Maybe I needed to recompile and I'm not seeing something correctly. There it is, my function, and it has a decal node. Oh, it doesn't have one. Oh. Oh man, okay. This was... The whole idea here is that this should not be able to connect to anything because it doesn't know what this is, in which case, when we generated the although why did that hook up? Because why was that able to find that? It should not be finding that. So this function call to my function, it should not have matched to this template. So why did it? That's confusing. How did it match in the first place? So this is a function call that takes a pointer to a integer storage. Oh, that is why. It did match, which makes sense that it matched, because that's a function that takes an integer storage. But okay, let's go to CodeGen here and function call. Function call matches decal, so if the names don't match, we immediately bail out. If the number of parameters don't match, we bail out. And then we look for each parameter. We should one-to-one match params. Ref param matches decal param. Right. The moment that I identify this thing, the moment I identify this thing as a function template, I need to break the connection of anything, any function call that thought I was a match. That's what needs to happen. That needs to be broken. I just hit the mic. If this is a generic function, but if this got converted to a generic function via the work above, we need to break the connection between us and any function calls. For each node of type in tree, expression function call. So for each function call, if node info expr function call dot, what is it called? Wait. Oh, function call. So no, if it's a function call, its first parameter, children 0, and node children 0. So here, we'll do this. For each function call, decal ref is this. If decal ref and decal ref info expr decal ref dot decal node equals the function, then we just need to break it. Okay. Let's try this again. Let's break here. And what did we say? Line 73. Function call line number is 73. So decal ref, what are you? My function, it's null. Okay. So far, so now we can step into here. We don't have any anything to do on our children. So for each function template, we need to find the one that matches us, which we did. So node should be the function template we just made. My function. Great. Let's look at the parameters. So Num call params is 1. The required params is 1. The extra params is 3. Wait, what? Oh, that happens way later. We're looking at num call params. Okay, yes. So those are the same. We're fine. Verify the parameter types match. So let's jump down here. Do parameter types match? No. They do not. Let's figure out why. So tantalizingly close to this. To this finally working. Okay, we found it. Skip over this. And why don't the param types match? So, okay, we've got the call arg type. So the type that we called it with is an integer storage 128 star. The template arg type is an any of, and the comparable type string is any of. If it's not an any, and it's not an any of, or it matches one of the any ofs. Okay, so the call arg type, which is integer storage 128, needs to match. Let's step into matches any of. Okay. Sure. Matches any of. So our query is integer storage 128. Num any of types is 3. It's got 3 of them. Num, or let's say any of types. Can I do that? Nope. I don't know how to tell VS Code to show me all of them. So let's look at all 3 of them. Nope. Okay. 104, 512, 128. We should match on this one, right? Those should match. Oh, but it's a pointer. Oh. It's a pointer. We lost the pointer in the translation here. Right, we lost the pointer somehow. Matches any of type. Call arg type. Any of types. I lost the pointer when I did this conversion. Is what happened. So when I did here, when I converted this to an any of. Although wait, how did I lose the pointer? I'm not updating the pointer. Let's do this. Print AST param before and after. It was an integer storage star. Now it's an any of no star. No star. How did that happen? Any of, am I just not printing? This should come after everything. first of all. So no, it's still a pointer. It's got a pointer depth. Any of. Where are we? Matches any of. Where did we come from? Oh, comparable type string appends pointers to it. I think. Codegen comparable type string. Where is that? Is that util? No, we pass in the pointer depth and it matches any of. Right. The any of types should include pointers if they have them on them. And I'm not doing that. Here. Here. Here, I'm not doing that. So, right. So we're gonna say new name. New name is this. Append references and pointers based on the depth. To do we need to do? I don't feel like thinking about this right now. Here too. This is annoying because we're doing this on the string. This should really be baked. It's already baked into the nodes. So I don't know why we're doing any string compare at all right now. Why are we still string comparing at all? The nodes themselves should have all this information. To do check all instances of comparable type string and see if they are needed anymore. Okay, we'll come to that later. So new name is the generated struct's name for pointer index. Depth ID is 0. What comes first? I don't even have references here, which is weird. It looks like references come first anyway, so this is on the, what is this on? This is on the parameter. Right? Yes, this is on the parameter. So if the parameter param info pointer reference depth. Depth ID. Okay. new name plus equals that. We'll do the same for pointers. I think I can just do that. Oh my god, we're working. That worked. I saw that it worked. So now we are properly... Okay. I don't need to append this here for any of. It's appended per type inside of it. So that's gross. The any of... Okay. The any of should be taking care of the pointer. The individual types inside of it should not be. This is messy. I don't like this. I'm going to undo what I did here. Right, so any of, these are all pointers. It's fine. We are working now, though. We are working. So if I call my function on, well, let's look at the generated code. There's my function. I called my function on an integer storage that was initialized at size 128. So that generated this struct up here, at the very top. And because I called my function with it, it generated my function passing the 128 version. But how did it know to do that? All I define down here is a function that takes an integer storage, and that's it. Well, it knows that because what it actually changed on the tree, let's open up the tree real quick. My function. So if you look, this function takes an integer storage. That doesn't technically exist because this struct, integer storage on its own, doesn't exist. What exists are what you generate off of it, which are these different sized ones, right? So what the metaprogram now does is when it sees a function decal that takes a templated struct, what it does instead is updates that function decal. It changes that parameter to, oh, this is the wrong one, my function. It changes that function to a function template, and it changes that parameter to an any of the possible structs that could be generated from it. Now, unfortunately, or maybe not, I'm not actually generating that anywhere so you can see it. But I guess technically it's just this with this changed to this, right? That. It just changes that implicitly from this. And that worked. So if I do this, this I think breaks, judging by that to do. Didn't mean to do that. No, that just works. That to do is outdated. If we don't ever use this, I think that just works. So what if I call, if I make an any struct 2 that takes a U32 and 1024 any, and I call test function on any. Does that work? It does. Let's stop printing all this nonsense out. And stop printing out this. Okay. And now in this function, let's just print for U32 index equals 0, index is less than value, array count value dot dynamic plus plus index. Let's just print out print value dot dynamic index. Okay. And we're gonna have, instead of 1024, because that's way too many, let's make one that has one thing in it, one that has two things in it, one that has 4, and one that has 8. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And so this should generate 4 of these, each that has U32s in them. You know what? Let's like the one that has 2 of them have strings in it. Why not? So it should generate 4 of these. One that has the arrays inside contains U32s, and this dynamic one is only one thing big. One where these are strings, and this is 2 things big. And then 2 more where these are both U32s, and one is 4 things big, one thing is 8 things big. Okay, so that broke, and I think it's because we're using this type in here. So let's see what it tried to generate. Any struct, any struct, any struct. Okay. Test function. So it tried to make one with this. What is the actual error? T has not been declared. Here. Oh, this is actually in print. Why did it try to generate something with just T? Oh, here. It's trying to print something of type T, because here this didn't get expanded into the right type. Here, any of these, when we called print, value should not be type T. And in fact, you can see they're not. So why did this try to generate with a T? So there's not a chance that this has to come after this, right? No, that's still a problem. And that didn't make any sense anyway. So, yeah, what is this about? What do you secondary chunk tried to do it too. So here it tried to make one with a T. Wait. What? 293. Oh, it tried to make a format string with it too. Why? This is not getting expanded here. Even though in all of these places, value here, that should just be working. Because it has the structs right here. You can see what they are. So, function templates. So, let's just add a print call. Let's do this. Here we will say if declref info expert declref dot decl name is print. Let's just make a break thing here. I want to step through this. We're good with these, I think. So here. Hello? What are you doing there? VS Code. Okay. Function call. What am I passing to you? String, which is literal string value. It's not that one. This is on line 117. I want this one. 117, that's this one. So let's also say declref line number is 117. So if I break here, this should be the one we're looking for. Print. Okay. Yeah, that should be fine. So this should be, the declref should not have a node that it's pointing to, which it doesn't. So let's look through this call and see what we're passing it. Does it know what we're passing it? A subscript whose left side is a member ref, whose right side is a declref. So this is the member ref right here. Its left side should be value. So its left side should be, wait, member ref. Oh, never mind. This is the first part. It is this binary operator, or this, wait. Is this the right thing? Oh, it is. Subscript. I'm not paying attention. Yes. Subscript first, and then the left side of the subscript is this, which is a member ref. The right side should just be index, which is a declref. Oops. So yeah, so this declref should say index, which it does. And this one should be a member ref whose left side is value and right side is dynamic. Left side is a declref called value, and it points to the parameter whose type we should know is any of. I think that's still okay. I think. And the right side of this is dynamic, right? Dynamic. And is that pointing to the right thing? Struct member of a struct template. And this struct member's type is T. Oh. So, right. This is pointing to a struct member of here, which is this thing, whose type is T. This print. Oh, what's getting generated first here? This is a problem. Uh-oh, this is a big problem. Let's just print out the name here. Print has to be coming first. It has to be. That's probably what's causing this problem. If print is coming first, that's a problem. Let's just see what's getting generated in what order. What am I looking through here? Function calls. Let's do it down here. I'm a little worried about this because this is a problem that I haven't thought through and is going to cause a lot of problems. So yeah, print is getting generated first. Or we're seeing this before this. Or I guess before these. But wait, don't I... If it's inside a function template, we shouldn't be doing this. And this one is inside a function template, is it not? Right? Because we do this first. This should not be a function template by the time we get here. This call should be saving us from this exact problem. Let's do this again. Let's put this back in here. And let's set this here. And what did we say? Line 117. Okay. So we failed this. The function call, according to this, is not inside of a function template. Because what are we in right now? Compound statement inside of a for statement. Right. Inside of a compound statement. Inside of a function template. Inside, what is that call doing? If it's failing me, inside function template. Containing function. Get containing function. Is function template. Oh, return, if... Wait, was this before I had AST meta function template? Return true. Does this ever happen if that right output assert false, assert message 1 false, false 1. 2. No, we never hit that. I don't need this. This whole function can be that. It can be this. Whenever I wrote this function, we didn't have this easy way to determine that. Okay, and that error about the t has gone away. Crisis averted, I think. Yeah, we're not trying to generate one with a t anymore. But what's the other error we're getting now? No matching function call for print, const char star, short string. On line 77. Here. We're trying to print out, is that this one? 2? Yes. It's the one trying to print out a short string. What did I do? Oh. It's one trying to print out a short string. Candidate 1 takes a U32. Why? Print takes an any. Oh, do I just not have... Wait. Hold on a second. Let's get rid of this. Does that work? Yes. Short string, test, hello world. There's no way this doesn't work. I'm missing something. Yeah, that works just fine. And what did that generate? Print. Right here. It generated this. So that works. In fact, if I do that, this should start working. Yeah. It's not able to recognize that this should generate a print function with a short string in it. Why? Let's just take a look. Not line 117 anymore. This is line... Wait, yeah, that should have... Hello? Why are you not breaking there? Oh, because that's not where it's going to be anymore. It's going to be... integer storage... test function. It's the one here. It's line 77. Okay, so this should be we should only hit one of these, and we do, so this is in the primary chunk. Okay, it already is connected to something. What is it connected to? The declaref is print, and it's pointing to a print function that takes a short string for the format and a U32. Why does it think it takes a U32? Because the function call, if I look at it, its secondary thing is a subscript. It's a member ref, whose second thing is a declaref, to dynamic, which is a struct member whose type is Short string. Why is this trying to match, or has already matched, with something that takes a U32? A print function that takes a U32. It has decided to match this with something that takes a U32. Why? I don't like it, I tell ya. Why is that happening? What can I step through to narrow this down? Let's go to code gen. When we hook up function calls, ref param matches function decal param. Okay, let's go here. Code gen 627. And let's start here and say that the function call line number 77. Function call. This should be oh, we were just there. 1, 2, 3. The decal is print. Okay. So what are we trying to match to? The decal that we're trying to match to is print, whose parameters are a short string and a what? U32. Why do we match this? We match the number of parameters. Oh, is it? Let me take a look on here. It might also be specifically Visual Studio. Might be a little hard to see, but let me double check. Thank you for letting me know. Yeah, it could be bigger. You are right. I guess it also depends on what you're watching this on, so I can make this a little bigger in VS Code. I'm not in VS Code for much of this, so okay. Appreciate you telling me that though. So, forget about this. We are matching param count. All right, now we're comparing each one. The call param is what we're looking at next. The call param is a literal string, because that's the first one. We don't care about that. The next one is subscript. Wait. Function decal param is a parameter. Here's what we want. The reference parameter is the subscript. The function decal parameter should be... Yeah, no worries. Thanks for letting me know. Should be the U32. We should not be matching on this because this subscript ultimately should be our string. All the way down here, it's a short string. We should not be matching on a U32. So why are we? Comparable type string. Okay, the function decal type should be U32, which it is. We are a subscript, so we go in here. We are a decal ref, so we go once again in here. Finally, we get to comparable type string. So the function decal type is a U32. We are a U32. Why are we getting U32 out of that? What? We were a subscript, which we are. So we want to check our left side. Oh. No, we're checking our right side. Why are we doing that? Is there there's no case where you would want to check that. That's messed up. Code gen. Where are we? 606? I can make this a little bigger too. So, where are we? 615? Yeah, if it's a member ref, we want to reference the right-hand side. If we're a subscript, we want the thing on the left, because the right is just going to be the index into the array, which is always a number. Okay. Where are we at now? Well, U32. Okay, now we are getting the short string version now, so that's working. But now we're getting two U32 versions because, oh, you know what? Wait, it's generating a U32 version. Why? So it's generating U32 is just a type def though, so why is it generating one for U32 also? Do I have type def in here? Instead of U32? Why is it generating both of these? uint32t, where did that come from? Does that tell me in here? uint32t and u32. So uint32t. Oh, hold on. Right. Because the struct that ultimately gets made from this has uint32t's inside of it, not u32's, which is not something I do in my code. So it sees this as two different things. That's frustrating. If the type is a type def, I want it to do code gen. If the type is a type def, append node as string. The problem is I don't know where in this stack this is happening right now. So when we generate a print function, return type, name, parameters, param type. You know what? Let's modify get param type. Get param type. If it's a type def. So the problem is stemming from the fact that this function call generates one of these. Hold on. If I remove this, is this still happening? Because I thought I fixed... Oh, but it's the change I just made that's now breaking this. So this is generating one of these structs that has a U32 in it. But that is getting turned into uint32t. Why? What did I just change here? Subscript, we're passing that. Let's look at when I'm generating the structs actually. Generate struct templates. So the type should be coming from here, which is a U32. So why is it generating with a uint32t? Here. That should not be doing that. Any struct 2 param node type get param type. Okay, let's if struct info decal struct dot name equals any struct 2. Do I have that? No. What do I call it here? Template. Let's break there. So we're gonna say breaking, not here. We're gonna break here. Nope. Okay. Any struct 2. The call site type for param is uint32. Why? Param node is a type T. param name is t. So it's a decal ref to decal name is 30. Oh, and it goes to a type def. Right. You know what? Let's not expand into the base type. There's no reason to do that. Type def alias. We're gonna keep the alias. And we work now. Okay. There's no reason to muddle those two things up if we're looking at them for names. So now, what we generate here is not the underlying type from the type def. It is the type def name, because that's what we should be using anyway. So, let's print out an extra /n here. And so we print out 1 number. We should print out 2 strings, 4 numbers, 8 numbers. How do we know that this worked? We'll say any1.dynamic 0 equals some number. Any2.dynamic 0 equals hello. And world. Any3.dynamic 0 equals 1, 2, 3, 4. And 4 dynamic 0 equals 2, 3, 1, 2, 3, 4. Okay. Boom. We're there. We have, let's remove, let's add an extra line here just so we can see what we're doing. Okay. And let's also add a new line here just to see what we're doing. Okay. So, given the fact that we have a generic struct here, you tell it what type is in these arrays, you tell it what size this dynamic array is, and then we have a test function, you pass it. Notice how I'm just passing it this base struct, right? And any struct too, right? And I'm just looping over however many values are in here, and array count, this is a static thing, it just counts the static, so in this case it would be 16 for this. How many things are in the dynamic array, print out each thing, generically. And then I have integer storage, which you can just, it has a generic size, or a parameterized size that you pass in. And again, we just print the size of that array. So I create 3 different integer storages of different sizes, and I print out the sizes of those buckets using that array count. And actually, my function should be doing that. Whatever. Oh yeah, I'm doing it right there. So, what is that printing out? Yes, okay. So this will print out generically the sizes of these arrays, and then I'm creating an any struct that has one U32 in here. I'm creating one that has 2 short strings in it, and one that has 4 U32s, one that has 8 32s. And if you go look at what we generated with that, here's our integer storages, here's our any structs. So here's 1 U32, 2 short strings, 4 U32s, 8 U32s, and I'm generating a my function for the one integer storage that prints it out. But I'm also generating all these test functions for the different ones I made. That's just printing out all the values in each of the arrays. So all that is generic, and here we go. Print out the bucket sizes, print out the small one generically. Here is where I'm printing out this test function 1. I'm printing out this number, but then I'm going to loop over all these and print out all the strings. Boom. Loop over the next one, printing out all the numbers. Final one, printing all the numbers. And this is technically all static. It's all static data, right? If you look here, none of this is dynamic memory being allocated, and yet my generic function, I can generate these structs of any size and type that I want. Oh boy. That's what I wanted to do tonight, was make this work. You can define a function that takes one of these templated structs, and it will generate functions for each one, which is cool. So you don't have to define, like, you don't have to care. You define your generic struct, and the function just take that generic struct and will generate the right ones for you. Damn, that's cool. So that worked. That took longer than I thought it would because I had to kind of rabbit hole in a couple things that were harder than I thought, but we're here. It works. I think I might call it now because that was a lot, and I call that a success. Let's push this stuff up. Functions can take generic structs, and they will generate the right things. Okay, and then more robust typing to facilitate generating any of functions based on struct template parameters, which we do now. Awesome. Okay. I call that a success. Thanks for watching. Follow me if you want to see more of this cool metaprogramming stuff. I think it's cool anyway. The next step is to handle macros, which shouldn't be too hard. I just have to think throughout about how... Basically, I don't want to have to support macros because they inherently don't exist in the tree as code. I've replaced them with snippets, which are basically like macros, but they actually are interpreted as code and put onto the AST. But we are missing some niceties from macros, like you can't stringify arguments you pass in, stuff like that, to build new variables and stuff. So there's stuff you can do with macros you can't do with snippets yet. So instead of supporting macros more generally, I'm going to just update, I think, the functionality of snippets to kind of support that stuff. So I think that's what I'll do next. And yeah, thanks for watching, everybody. I will catch you next time.